Statistics 3, hypothesis testing. So type 2, test statistic. Example, we have a company manufactures pens with a mean writing life of 500 hours and a standard deviation of 10 hours. A retailer examines a sample of 81 pens from a supplier who claims to only sell pens from this company and finds their mean life is 497 hours. Are these pens genuine products from the company? So the first thing we want to do is set up our null hypothesis. And for our null hypothesis in our test statistic, we always say that the mean has not changed, right? So therefore, what is our mean? Well, they're saying that the mean writing life is 500 hours. Okay, so therefore that's 500 hours. If you were to write that in words, you could say this is the genuine product. Okay, our alternative hypothesis then means that the mean has changed. In other words, the mean is not going to be 500 hours. Now, often in college when we're doing these, you're looking specifically at whether the mean is greater than or less than this value. But for us, for Leaving Cert, we're just saying it's not equal to the 500 hours. So we're looking at the two extreme ends, okay? So our next step is to look at our test statistic. And to do that, we know that the formula is our sample mean minus the mean over the standard deviation divided by the square root of n. So therefore, what values are we given here in the question? Well, we can see our mean is 500 hours. Our standard deviation, if we look at the question, is 10 hours. Our sample size, well again, if we look at our sample, he samples 81 pens. And then the mean of the sample finds the mean life is 497 hours. So if we sub this into our formula, we end up with 497 minus 500 over 10 divided by the square root of 81. And therefore that gives us a test statistic of minus 2.7. So this is our test statistic. Okay, so our next thing that we are going to do, our step 3, is to sketch a graph to see whereabouts does this test statistic lie. So we're going to draw a nice big graph. And on the graph, we're going to mark our critical values. Our critical values being 1.96 and minus 1.96. And therefore, this red shaded region here on either side is known as the critical region. Okay, now if we look between 1.96 and minus 1.96, we would say that we fail to reject HO. This is our 95% of our graph. If we lie beyond this area, then we fail to accept our null hypothesis. And this is our 2.5%. And again, if I go beyond in this direction, we also fail to accept the null hypothesis. And again, this is also 2.5%. So we draw this graph every time we're doing our test statistic so that we can clearly identify where our test statistic lies. So if we go back, what did we work it out to be? We worked it out to be minus 2.7. So it's on the left-hand side of our graph here. So minus 2.7 is roughly around here. So this is where our test statistic lies. So we can say, well, minus 2.7 is less than minus 1.96. So therefore we draw our conclusion in step 4, and we say we fail to accept our null hypothesis as minus 2.7 lies in the critical region. Well, what does that mean? Okay, we have to interpret this. So we say, hence, there is evidence to suggest at the 5% significance level at the 5% level of significance that as the mean the mean writing life of the pens has changed. And if the mean writing life of the pens has changed, well, that means that the pens are not genuine products. Okay? So some people might say, well, why not set up a 95% confidence interval here and test that for our claim instead? And the question can be answered with simply, you could do both, okay? But it doesn't actually state in this question to set up a 95% confidence interval. It also doesn't state to test it at the 5% level of significance. So you can do either. But this example is specifically looking at test statistic, okay? So let's have a look at the second example. So again, in this one here, we have a tyre company claims that the mean life of tyres that it produces is 11,000 miles with a standard deviation of 552 miles. An independent supplier of tyres wants to investigate the company's claim. A test on a random sample of 36 tyres from the company gave a mean life of 10,000 miles. Carry out a hypothesis test using a significance level of 5% to see if there is evidence to support the company's claim. So in this question, it does specifically say significance level of 5%, which would generally draw me to doing the test statistic as opposed to the 95% confidence interval of a mean. So again, we're going to start. Our step 1 is to set up our hypothesis and talk about which is our null hypothesis and which is our alternative hypothesis. So our null hypothesis is always that the mean has not changed. So what is our mean? Well, if we look at the question, it says that it has a mean life of, so if we underline, so a mean life of 11,000 miles. And therefore the alternative is that the mean has changed. In other words, that it is not 11,000 miles. Okay. Our next step then, or step 2, is to work out our test statistic. So our sample mean minus the mean over the standard deviation divided by the square root of sigma over root n. And again, can be found our standard error of the mean in our maths tables. And if we look, what are we given? Well, our mean is 11,000 miles. Our standard deviation, well, if we go to the question, so standard deviation is 552 miles. If we look at our sample size, well, it's a random sample of 36 tyres. And our sample mean, well, it says the mean life from the sample was 10,000 miles. So let's work out our test statistic. So we have 10,000 minus 11,000 over the square root of 552 divided by the square root of 36. And that gives us a value of, and this gives us a value of minus 10.87. Now we can already see this is an extreme value here. Okay, so this is our test statistic. Okay, so we still have to go and finish our claim, which is step 3. So again, we draw our graph. We mark in on our graph 1.96 minus 1.96 are critical values. Therefore, less than or greater than these values is the critical region. So again, clearly identifying our critical region on our graph. If we're in this region, we fail to accept HO. Whereas if we're in this region in the middle, we fail to reject HO. This is 2.5%, this is 95%, and 2.5%. Okay, so ours is a very extreme value, which is going to be way over here, minus 10.87. And it's unlikely you'd get an extreme value like that in your leaving cert, but it's always good to show you extreme values in examples. And again, the reason we wouldn't get an extreme value like that is obviously we can't get those values from our tables if we were to test our p-value, which you'll see coming up in your next example, okay? So what do we say? Well, we say minus 10.87 is less than minus 1.96. So we're going to draw our conclusion. And we can say we fail to accept HO as minus 10.87 lies in the critical region. And we make our conclusion. What does this actually mean? So we say, hence, there is evidence to suggest at the 5% level of significance that the mean life of tyres has changed. Okay. So it's the company's claim has basically is false, really. Okay, but again, we're not 100% certain of that. We can never be 100% certain in our statistics research. Okay, so we only conclude that there's evidence to suggest at the 5% level of significance that the mean life has changed, based on the fact that our test statistic is lying in the critical region. Now, for test statistics, does not lie in the critical region, in other words, it lies between minus 1.96 and 1.96, then our conclusion would be that we fail to reject HO as it does not lie in the critical region, and hence there is evidence to suggest at the 5% level of significance that the mean life is 11,000 miles. Okay?